Hello everyone. In this video, we'll be solving problem 125, valid palindrome. The problem statement is, given a string S, return true if it is a palindrome. A palindrome is a string which reads same forward or backward. Another given statement is that we only need to work with alphanumeric characters and removing all non-alphanumeric characters from the string. So if there are any special characters in the string, we need to ignore them and only compare the alphanumeric, like that is alphabets and numbers. And it needs to be case insensitive. If you look at example number 1, we have a string with several characters, and if we remove the special characters from it, like the spaces, commas, and the colons, this is what the output looks like. And if we look at it backwards, it is the same. In example number 2, if we remove the special characters, this is what the string would look like. The first few characters in the beginning and in the end are the same, but the ones in the center are not. So we return false. If there are no alphabets or numbers in the string, we return true. The constraints that are given to us are the length of the string will be anywhere between 1 to 2 into 10 raised to power 5, which means the string length would be huge, and S consists only of printable ASCII characters. Let's dive into whiteboard and discuss how we can solve this problem. I'll use example number 1 to understand. For a naive approach, the simplest way to solve this problem is to create a new string S1, which will be the reverse of the S input that is given to us, and then we'll compare if S is equal to S1. So if we were to reverse this string, it would look something like this. And now if we compare S1 and S2, the output will be false, as there are a couple of characters in the string which are not equal. This solves the problem, but the time complexity for this one is going to be O of 2n, as we are first creating this reversed string and then doing the comparison character by character. And the space complexity is O of n, as we are using this new character of length s. As this is not an efficient solution, let's think about how we can make it better. One better way to solve this problem is to use two pointers, where one pointer will be pointing to the start of the string and the other pointer will be pointing at the end. We'll compare if the corresponding characters are equal. If they are, then we'll continue the iteration further by incrementing the first pointer and then decrementing the last pointer. If at any given point of time we encounter a no where the strings are not equal, we'll just exit out of the loop and return false. As we iterate through the entire string, if at any given point of time we don't encounter a no scenario or there is no false, we'll return true. While we are doing this iteration, if we encounter any special characters, we'll ignore it. Let's do a couple of runs to understand how this should work in action. So to start with, our SI, which is the start index, will be 0, and SE, which is the end index, will be pointing at the last character, 7. The character that SI is pointing is R, and the character that SE is pointing is also R. Please note that I'm ignoring the case of each character because the two are equal. We'll continue the iteration. So in the next run, we'll increment our SI to 1, decrement SE to 6, and compare. I have A on both the sides. They are equal, so we'll continue. Let's say I have a space in between here. Let's do that combination as well. So I'll just change these pointers one more time to reflect the new values. So we started off with 8, which is R, then 7, which is A. Now in the next run, I'll increment my SI pointer, which is 2. SE will become 6. My SI is pointing at C, while my CE or SE is pointing at space. They are not equal, but CE is a special character, so we'll ignore it. In the next cycle, we'll only decrement the SE pointer, leaving the SI as is. So for the next comparison, my SI will be 2, SE will be 5. The value of CI will stay the same, which is C. And then SE is pointing at C, which is equal. So we'll continue the iteration. We'll do that until we encounter a false statement or the characters do not match. If we don't encounter one, we'll return true at the end. The time complexity of this solution is O of n, as we are only iterating through the given string once, and n is the length of the string, and our space complexity is O of 1. as we are not creating any new string to maintain the reverse order. We are just comparing bit by bit or character by character and determining if they are equal or not. I hope you were able to understand this explanation. Let me show you how we can implement this using C#. Here is my C# solution. I start by adding a couple of conditions where I'm checking if s is equal to null or s.length is less than 2. If either of the conditions are true, I'm returning true without going into the while loop. If the conditions are not sufficed, I'm then initializing two indexes, s and e index, and setting the default value to 0 and s.length minus 1, and then starting a while loop until s index is less than e index. After that, I'm checking if the pointer that s index is pointing is it a character or a digit. If it is not, then I'm simply incrementing my s index and continuing with the run. I'm doing the same thing on the next line with e index and decrementing the e index if it is a special character. If either of the conditions are not suffice, which means they both are pointing at a valid characters or string, I'm then comparing if the values that si index and e index are equal. If they are not equal, then I'm returning false and exiting out of the while loop. If they both are equal, then I'm incrementing my s index and decrementing my e index. After the while loop is done and we have not encountered any differences, I'm returning true at the end. This code, when submitted on LeetCode, beats nearly 58% of the submissions in terms of runtime complexity and 58% in terms of memory consumption as well. Thank you for watching this video. I hope you were able to understand this explanation and the source code. The link to the code is available in the description below. Feel free to check that out, and I will see you in the next one. Thank you.